So hi guys, it's me again Angie. Welcome to another video. For today's video, I'm going to discuss about the combined analysis of topologies. Media access control is the equivalent of traffic rules that regulate the entrance of motor vehicles onto a roadway. The absence of any media access control would be the equivalent of vehicles ignoring all other traffic and entering the road without regard to the other vehicles. However, not all roads and entrances are the same. Traffic can enter the road by merging, by waiting for its turn at a stop sign, or by obeying signal lights. A driver follows a different set of rules for each type of entrance. In the same way, there are different methods to regulate placing frames onto the media. The protocols at the data link layer define the rules for access to different media. These media access control techniques define if and how the nodes share the media. So the actual media access control method used depends on the topology and the media sharing. What is topology? Topology is how the connection between the nodes appears to the data link layer, while media sharing is how the nodes share the media. The media sharing can be point-to-point, such as in one connection, or shared, such as in LAN networks. So, physical and logical topologies are, are LAN and WAN topologies. They can be classified by physical and logical topology. Physical topology refers to the physical connections and identifies the how end devices and infrastructure devices such as routers, switches, and wireless access points are interconnected. Physical topologies are usually point-to-point or star. So as you can see in the figure, it could be a point-to-point or a star topology. While in logical topology, it refers to the way a network transfers frames from one node to the next. This arrangement consists of virtual connections between the nodes of a network. These logical signal paths are defined by data link layer protocols. The logical topology of point-to-point links is relatively simple, while shared media offers different access control methods, as you can see here in the second picture. So there are common physical WAN topologies. These are the point-to-point, hub and spoke, and the mesh. So this is the point-to-point. This is the simplest topology that consists of a permanent link between two endpoints. For this reason, this is a very popular WAN topology. So in the next figure, we can see the hub and spoke. This is a one version of the star topology in which a central site interconnects branch sites using point-to-point links. And the last picture shows the full mesh topology. This topology provides high availability but requires that every end system be interconnected to every other system. Therefore, the administrative and physical cost can be significant. Each link is essentially a point-to-point link to the other node. What is a physical point-to-point topology? Physical point-to-point topologies directly connect two nodes as shown here in the figure. In this arrangement, two nodes do not have to share the media with other hosts. Additionally, a node does not have to make any determination about whether an incoming frame is destined for it or another node. Therefore, the logical data link protocols can be very simple, as all frames on the media can only travel to or from the two nodes. The frames are placed on the media by the node at the end and taken from the media by the node at the other end of the point-to-point circuit. So what is a logical point-to-point topology? So as shown in this figure, the source and destination node may be indirectly connected to each other over some geographical distance. In some cases, the logical connection between nodes forms what is called a virtual circuit. A virtual circuit is a logical connection created within a network between two network devices. The two nodes on either end of the virtual circuit exchange the frames with each other. This occurs even if the frames are directed through intermediary devices, as you can see here in the second figure. So, physical topology defines how the end systems are physically interconnected. In shared media, LANs and devices can be interconnected using this following physical topologies: the star topology, the extended star topology, the bus topology, and the ring topology. Star topology is the end devices are connected to a central intermediate device. Early star topologies interconnected end devices using Ethernet hubs. However, star topologies now use Ethernet switches. The star topology is easy to install, very scalable, and easy to troubleshoot. Then the extended star, as you can see here in the next picture, in an extended star topology, additional Ethernet switches interconnect other star topologies. An extended star is an example of a hybrid topology. The next one is the bus topology. All end systems are chained to each other and terminated in some form on each end. Infrastructure devices such as switches are not required to interconnect the end devices. Bus topologies using coax cables were used in legacy Ethernet networks because it was inexpensive and easy to set up. And the last picture shows the ring topology. End systems are connected to their respective neighbor, forming a ring. Unlike the bus topology, the ring does not need to be terminated. Ring topologies were used in legacy fiber distributed data interface and token ring networks. So as you can see, here is the ring and the devices are being connected with each other. The figure illustrates how end devices are interconnected on LANs. It is common for a straight line in networking graphics to represent an Ethernet LAN including a simple star and an extended star. So this is the end of my video. Thank you for watching. See you on my next video.